question in this video is how do we solve complex circuits? A complex circuit is a circuit which has combinations of both parallel and series circuits. And we'd already learned about how to solve parallel circuits and how to solve series circuits. So we're going to use the same ideas and the same techniques to solve a complex circuit. We see here with this circuit, we have a 15-volt battery. It's connected to 3 resistors, a 2 ohm, a 6 ohm, and a 6 ohm over here. They are not in series because it's not one single loop. And they're not all in parallel because they don't all look like a box kind of shape like this. But it's really a combination of the two. So the first thing we're going to do when we're solving for a complex circuit is we're going to combine circuits until we get to the point where they're all in parallel or they're all in series. And once they're all in parallel or all in series, then we know how to solve and we can work from there. So right now, what we have to do is decide which of these resistors are in series and or parallel. So we start here that we look at, let's say, resistor 1 and 2. These resistors are in parallel with each other because they have both sides touching each other with only wire in between. So, for example, here, the left-hand side, the sides touch with a wire, and the right-hand side, they touch with a wire as well. So in a parallel combination, the sides touch each other. You may have multiple, you may have like 3 or 4 in there, but as long as the left and the right sides touch each other, that's all that matters. So they are in series. You may want to say, well, look, aren't resistor 1 and 3 in they're in parallel. They're in parallel. But you might want to say, aren't resistor 1 and 3 in series? And the answer is no. In order to be in series, you can then draw a line that goes between those resistors without there being any kind of a junction or battery in between them. So because there's a junction or split in the wire, resistors 1 and 3 are not in series. In order to be in series, they must have only wire, no junction in between. No junction in between. It can bend like that. These 3 are in series. There's no junction, there's no split in the wire. So we are going to combine resistors 1 and 3 and replace them with a single resistor. We want to know, well, what is the resistance of that single resistor? Because they're in parallel, the combined resistance is going to be adding their inverses, 1 over 2 plus 1 over 6. And as we add this, it gives us 0.6 repeating. And then what we want to do is we want to find the equivalent of that by taking the inverse of 0.6 repeating. So we have to take 1 over 0.6 repeating, and this comes out then to be 1.5. So what we're going to do is we're going to redraw this circuit. We're going to replace these two with a single resistor that is 1.5 ohms. So I'm going to redraw this circuit. I had my 15-volt battery, and we're going to replace that combination with a 1.5 ohm resistor. Now we still have the 6 ohm resistor over here on the side. That has been unchanged. When we look at this combination here, we see that these are in series with one another. And so at this point, we can really solve this circuit just like we did in the past. They are series. So first thing we do is we solve for the equivalent resistance. This is the resistance at the battery. Because they're in series, we simply add them together and get 7.5 ohms. So the resistance seen by the battery is a total of 7.5 ohms. Once we know 2 out of the 3, then we're going to solve for the third using Ohm's law, which says that V equals I times R. Here we have V is 15, R is 7.5. And we get that the current comes out to be 2 amperes. Now in a series circuit, all of the currents are the same. So if this is 2 amperes, then all of the currents are 2 amperes as well. Once we know 2 out of the 3, then we solve for the third again using Ohm's law. So here we have the voltage we're going to solve for. That is 2 times 1.5, and so that comes out to be 3 volts here. Here again, we have the voltage is 2 amperes times 6 ohms, and that comes out to be 12 volts. Now what we do at this point is we work backwards. Remember that this circuit here was actually 2 in parallel. Okay, if we look here, it's really these 2 combined. Now in a parallel circuit, we said that the voltages are the same. So this was a 3 volts, and that means that the voltage of the other 2 are also 3 volts. So we use the same ideas. In a parallel circuit, all the voltages are the same. In a series circuit, all the currents are the same. And once we know 2 out of the 3, then we solve for the third using Ohm's law. So here we have 3 volts equals I times 2 ohms, and we get that the current is 1.5 amperes. Here we have that 3 volts is equal to I times 6 ohms, and we get that the current is 0.5 ampere. Now to get the other 2 things here, we already have those from right here. The battery is still 15 volts, 7.5 ohms, and 2 amperes. This 6 ohm resistor is still 2 amperes and 12 volts. And so we solve for everything at each resistor and the battery in this complex circuit simply using our ideas of series and parallel circuits that we've learned in the past. The idea is to combine any resistors that you can until they're all in series or all in parallel, solve that circuit, and then work backwards. It doesn't matter how complicated it is, it's the same idea. You combine until they're all in series or all in parallel, and then you work backwards.